Hi. In this lab, we are going to use rewrite policies and responder policies in Citrix ADC. Let's see how we are going to use this feature. Okay, let's see. Currently, there is one URL 172.21.10.101. 172.10.101 slash home.php. So this is the one website which is currently available. Okay, so user accessing this URL, but the issue is when the user accessing this URL, okay, but uh, user don't know about that home.php. Okay, so we want whenever user just type 172.21.10.101 in a browser, then user should get the home.php page. So currently here you can see 10.101, currently this page is available, server index dot is, but home.php we have this blue home, that server info page. Okay, so this page and this page is different, right? Because this is 10.101 and this is slash home.php. So we want, without entering that home.php also, user should always get this page. Okay, even though user is not writing home.php after that. So we want to rewrite a page if a request comes with the once with default page, which is including only this slash. Okay, it should add home.php in it. Okay, and send a request to the server, so user will get this page directly. Okay, so with this URL also, without it will not show home.php in a page, but user will see this page. Okay, so how we can do that? So with the help of app expert rewrite policies. Okay, so going forward, we'll go to the rewrite policies. Okay, rewrite policy, we will create a policy. Okay, just give a name to the rewrite policy, RW policy send to home. Okay, the action you want to add. Okay, so the action is rewrite action send to home. Okay, so we want to replace, right? Want to replace that slash. Okay, so expression target where we want to replace in HTTP request URL path. The URL path we want to replace. Okay, the URL path we want to replace it with home.php slash home.php. So, so we want to replace where HTTP request URL path, and what we want to replace with slash home.php. Okay, just create. Okay, now in expression when we want to take an action, right? So when we get HTTP request URL path that equals in URL path if equals to only slash. If URL path equals slash, okay, so create. This policy is now created. Now we want to apply. We want to apply and what load balancing virtual server. This is a request and this is LB virtual server RBG. This is the same version 21 10.101. So this is IP. So continue. Which policy we want to apply? There's only one policy we have created. This is select priority 100. Just enter next. Bind. It is done. Okay, so policy is now applied. You can see there is no any hits. Okay, so only slash if is now see, this is default page. Okay, this was previously working, right? But we are looking for only dash, okay, equals to in the path we are looking for only equals to slash, but here we are already having home.php, so it will not hit this policy. Okay, but this URL you can see in the path we have only slash. Okay, so this is our interesting traffic, and here we are going to rewrite with home.php, right? So just refresh the page and see the page has modified now. But if you see client not able to see that home.php, okay, right here we can see home.php, okay, but here in a rewrite policy without showing user the actual path, it will redirect automatically to the server. Okay, so it's a transparent. Okay, let's see the hits on the Netscaler. We will find, just refresh. See, there are 2 hits, right? If you want to generate more traffic, and see the hits. See, there it is. So this is how we can use rewrite policy. Okay. Now, one more thing we can do, we can delete HTTP headers. Okay. Okay. So deleting the HTTP header, we need to use live. Oh, we can see in a Chrome also. Okay. Okay. So we want to delete, okay, HTTP header, something server header or something. See, now this is the page. We will just open developer tool here. Okay, so network. Okay, so this page I'm going to just refresh, and we will see the home.php's headers. Okay, here you can see in a header, if I'm sending a request, okay, I'm getting a response, okay, and in response I have everything data, just connection, keep alive, content length, that is keep alive, server. So it's showing a server is Apache 2.4.6. So this information is something which the organizations don't want to publish, right? For security reasons, they don't want to publish what type of server they are hosting, right? So this is Apache, okay, Apache 2.4.6, where my this website is hosted. So we don't want to publish this server tag or server header to the user. Then how we can do that? Okay, so for that we need to rewrite policy. Okay, where we will remove that server ID. Okay, simple rewrite policy remove server ID. Okay, action, we want to take an action on that. So this is rewrite action remove server ID. Okay, type what we want to remove something, right? So we want to delete HTTP header. So this is the action we want to take care. Delete HTTP header. Okay, the header name is server, because this is the server header name which is matching, right? Is server. This header we want to delete. Okay, no problem. Create. Now, no expression. Okay, the expression is you want to delete a server, but where where I get that uh, mm, server header when I want to when I should delete that server header. Okay, so you need to delete it when HTTP response is valid or is successful. Okay, when I get a response from a server, in that response take an action and delete that server header. Okay, so the rewrite policy we have just created, what is that? We created, oh, we are not added here, something problem, add, oh, we not created, we just close that page. Okay, so delete HTTP header name rewrite write action remove server ID. This server name server create. Okay, action name is already in use by rewrite action. Rewrite action. Oh, but why not showing rewrite action then? Just a second. Let's see. Oh, rewrite action sent to whom? Then where is our non-drop is different. Action name is already there, but it is not showing RW. Our action is not showing here. There sometime GUI. Okay, so let's add new rewrite remove server ID. We change the name. Okay, so we want to delete HTTP header, and that header is server and create remove server. So rewrite remove server ID value create. Just refresh. It works slow. Okay, now here it is. Okay, now we want to bind it. Go to the policy manager, bind it to the load balancing, go to server RBG, continue. Okay, add binding. Which policy we want to bind here? Rewrite remove server ID. Select next bind. Policy cannot be bound to specified policy label. Policy label. Just a second. Let's see what is the problem here. edit. This is a response, right? Yes. Policy manager. Oh, this is a response. Okay, sorry. This is a response page, right? So load balancing virtual server. Connection type is response because whenever server response, then only we can delete that server header. So that's why. So remove server ID, select and click the next. Bind, done. Okay, let's see. Okay, so just close it. Again, we just refresh the page. Now see, again I got the home.php, and again if we see that response headers, in the response headers that server header is not mentioned. You can see we have just requested, but in a response that server header is not available. Server header has gone. Okay, now that's okay, but we just remove the server header. See, there is no any server header. Okay, but it's not the case. We want to add a server header also. Okay, so in a response, we should get a server header with some name. Okay, some unknown name like my name Saga. So we can add a server header. Okay, we can add a server header. So just create a policy uh, like rewrite policy new server ID. We will add server ID here. Okay, add. Okay, rewrite action new server ID. Okay, we want to insert HTTP header. Okay, so which HTTP header you want to add? Server. Okay, so we want to add server header and expression. Here to what server ID you want to add. Just type my name, Sagar, anything. 1 2 3 4 5 6. I want to add. So this should be my server header. Okay, so server header and the server name will reflect as Sagar 1 2 3 4 5 6. Right? Okay. When you want to add that server header, then again it's the same. When HTTP response is valid. When I get the HTTP response is valid. If I get a valid response, I would like to add server ID. Okay, great. So now it's showing 2 policies only. Just refresh, and you will see 3 policies. Okay, so new server ID, policy manager, load balancing virtual server. Oh, this is HTTP only, but this is a response. In a response, the same page, just going to add response server ID. See, same we can see under virtual server, traffic manager, load balancing, virtual servers. This virtual server RG 121.10.101. So here we can see there should be two response policies. So okay, so rewrite policy and response policy. So here it is showing the remove server ID. Okay, that only policy showing available. So we want to add response policy here, that newly created new server ID. select 110 is also next, bind. So now we have two response policies. Okay, done. Okay, now if you see previously, first we remove the server ID, so now there is no any server ID, but now we want to add a server ID in a response header. Currently there is no any server header, right? So if I refresh the page, oh, we should see that server with Sagar 12345 6. So just refresh the page and let's see home.php, and here we can see that server response header with Sagar 12345 6. Okay, so this is the header. So we just implemented a rewrite policy. Okay, now uh, now there is one issue that company has observed, that home.php is a URL. Okay, but that home.php is a case sensitive, means if any user by mistakenly type OH in a home in a caps lock, then user face an issue. Just a second, let's we type it in the browser. Suppose it's typing H in caps, so you just see this page. But if you just type in small home, okay, small h, then only it opens. So it's a issue that company wants. It should not be a case sensitive. Okay, at home.php, if any user typing in a caps or small, it should not be the case that user not able to access that website. So we want to fix this issue. Okay, to fix this issue, again we need to create a rewrite policy for that. Okay, so again go to the app expert, rewrite policies, add. Okay, so the policy, create rewrite policy, replace path with lowercase. So we want to replace with the lowercase. So if I receive a request path in a caps, okay, then I will replace it in lowercase. Okay, so we'll take an action. So give a name action, write action, replace path to lowercase. Okay, that's good. Now in the type, what is the type? Okay, so we want to replace something, right? So just type a replace. Okay, what we want to replace? So it's a target where we want to replace, right? So we want to replace at http request URL, where http URL safe to lower. So this is the target. Okay, so we want to replace. Okay, enter this expression in the expression to replace with. Okay, so this is what we want to replace with. Okay, and we just want to request URL. Here we want to replace HTTP request URL. Okay, so our target is HTTP request URL, and we are going to replace with HTTP request URL, HTTP URL safe to lower. Create. Okay, so when we will apply this policy, right? When we will take that action, we'll take that action when HTTP request URL matches something like regular expression. We can use regular expression match. Okay, if it match my regular expression, that is r slash if it is between caps lock A to Z, anything A to Z, if I find anything in a caps, okay, in A to Z in whole URL, okay, then I will convert and then I will take that action. Okay, so this is the regular expression. Okay, just create. Okay, now I want to apply this. So I want to apply at load balancing virtual server HTTP. This is a request. Virtual server RBG. Continue. Okay, we want to add 110 next bind policy is upper lowercase, select bind, done. That's it. We are configured. Now check that home.php is already working, but if I type home, now see home.php is also working. So this home.php from me to server, it is showing in a caps, but from server to the client, it's actually going in a lowercase. So home.php, if I type an m in a caps also, then also it will work. See, now there is no any issue at the client level because it is getting override by the Citrix Netscaler to the lowercase. If you see the hits, just refresh it. Let's see, this is 4. So this is how the override works. Okay, so DNS below. Okay, now we will do one activity that DNS will rewrite TCP header. Okay, the TCP header, something like the company has configured virtual server to load balance LDAP servers. Okay, here we can see in traffic management virtual server we have LDAP servers port number 389. Okay, so LDAP server is for authentication. So clients are getting authenticated first with the LDAP server, and then it get access depends on whether the user log in or not. Okay. So for that, but the company wants that LDAP servers, okay, needs to know the end user actual user's IP address. Okay, so so currently LDAP users getting source IP as a Netscaler IP, because from client to Netscaler and Netscaler to server there's a different IP, right? So Netscaler using SNIP to communicate with the backend servers, LDAP servers. Okay, but LDAP servers wants to know the actual IP also. Okay, so for that we can use with the rewrite option or option here to fulfill the same. Okay, so again we can do a policy, rewrite policies, add policy, just type rewrite insert TCP policy. Okay, now we want to add a header. So rewrite action. So rewrite action, just type rewrite insert TCP action. Okay, we want to insert HTTP header. That will not work because we want to insert before. Okay, so because we are sending from Netscaler to the backend servers. Okay, so we want to insert it before. Okay, so before inserting means because the client IP will be the actual client IP will be available on the ADC. Okay, so before that packets that HTTP header, okay, sends to the backend server. Okay, before that we want to add that client IP in that TCP payload. Okay, so the expression to choose target location. Okay, the target location is client TCP payload. So our target location is client TCP payload. So this is a client TCP payload which we are going to send to the server. Okay, backend server. Yeah. Okay, so expression. How, so what we want to, okay, to insert expression to insert with. Okay, how we want to insert that setting. So we want to insert from from uh, from client plus client IP source. Okay, so this is we want to insert expression to insert with. So this is the expression we want to add in that payload. Okay, so so that backend server will get that information. So create. Okay, so it's created. Now it is sending expression when we want to apply that action, whenever we get a request for that LDAP server. If something is accessing request server, then its actual IP should add in that payload. Okay, this is the policy. Again, we want to bind policy manager on the load balancing virtual server, and this time it's a request, but this is not HTTP, right? This is a TCP because we are using LDAP, right? So we have an LDAP server here. Okay, and the next grab bind. Oh, sorry, the select policy, the TCP board true. Bind done. Okay, so policy is now applied. So anytime when user log, it will get actual IP, but we want to confirm whether the end server, backend server will get an IP or not. So for that, we create a session where uh, we'll take a NS trace for that. Okay, start new trace. Packet size 0. Okay, start. We can just add here. You can see connection IP equal to what is the LDAP server IP 172 oh, 172 21 10.103. Okay, so the request to 172.21.10.03. So this is connection dot IP dot equal to 172.21.10.103. Right, done. We don't want to try. We don't want to, peer traffic here. Okay, so just start. Okay, so once you start, what we need to do here? Okay, trace is started successfully. That's okay. We have to telnet 172.21.10.103 port number 389. The port is opening. So I am telnetting from my system, and my system IP is actual IP is 172.21.10.254. Okay, that's good. Stop and download. Okay, so we can just download it. Okay, so just open. Let's see. We should get the quest. So 172.21.10.254 is my actual IP, but I am hitting to virtual server, right? Not the actual server. So the actual server will get the SNIP as a source IP only, right? Okay, see here. I am sending 172.21.10.254 to 172.21.10.103, port number 389. Okay, so this is 3GP three-way handshake. It happens here. Okay, but the backend communication, if you see the backend communication, it happens between 192.168.10.103, and this is the actual backend server 192.168.30.11. So this is SNIP 10.103, and this is backend server 10.11. Okay, so these are the packets, okay, where we want to see that we are sending the actual IP to the server. So the follow TCP stream. Here we can see, as per our syntax, where we mention it should see from client 171.10.254, right? So this is a communication happens in the backend. Okay, 1.10.103, this is showing a source and this is showing a destination. This is the communication, but in the payload we have modified and sending our actual source actual client IP to the backend server. If you on, you can see the policies hits here. Policies, rewrite policies. Saint TCPL, see there are two hits. Okay, so this is how we can modify and add TCP payload. Okay, now we will redirect from HTTP to SSL. So HTTP to SSL we can modify. So we will use a responder policy to do that. Okay, so to, there is, let's go to the traffic management virtual server. There is already LV virtual server redirect. Okay, so LV virtual server redirect, whatever the request coming to 80 is redirecting to virtual server RBG. Okay, that is 443.171.10.105. So that is already working, right? HTTP 172.21.10.105. So it is already redirecting, right? If you see, I just type HTTP and it's redirected to HTTPS, because on this group we already redirected URL is there, HTTPS 172.21.10.105. So if a request comes to that, then it will redirect to the HTTPS. But here we want to use with the responder policy. Okay, we don't want to use that redirect URL. We want to use responder policy for that. So there is another way where we can do that. Okay, but for there is a condition to use a responder policy, that this server should be up, and to redirect URL the condition is the server should be down. Okay, so to use that responder policy we need to first make sure that that server is up. To make it up, we want to add a service, any fake service. We can make fake service. Okay, so any IP we can use 1.1.1 HTTP, but make sure that service is not getting monitored. Health monitoring I just disabled. Okay, because this is a false, right? False service. So this is enabled, done, bind, and done. Okay, now we can see the SSL redirect that port 80 service up, but now in this case that HTTP will not work. So we just remove the HTTPS and we just type, see, we are getting that error that HTTP is not working. So redirect is not happening over there right now. So in that case we can configure a responder policy. Okay, to configure responder policy, again go to the app expert, go to the responder policies, add policies, RS policy, send to SSL, send to SSL. Okay, so we will create an action action name, rs action send to SSL. Okay, the type is redirect. We want to redirect, right? Okay, redirect what? We want to direct expression HTTPS. HTTPS. We want to redirect HTTPS / colon plus whatever your HTTP request host name, request dot host name, HTTP URL safe, okay, plus HTTP request URL path and query and path and query HTTP URL safe. Okay, so this is response status code will be 302 because this is redirecting something, right? So response code, see this one, reason phrase, we no need to mention here. So this is the responder action. So create. Okay, when we want to take an action, you want to take an action, let's go to the return, select the request is from, it's a client request for SSL, and that is SSL. Okay, done. Is client requesting for quest for SSL, but if it's not, if client is not requesting for SSL, then I will take this action. Okay, so created policy manager, I'm going to bind it, right? Policy manager to the load balancing virtual server. This is TTP. You have a LB virtual server redirect. Continue. Policy send to SSL. Select expression, next, bind. Is saying nope, non-terminating action. This is something bug. Actually, every time I configure and add without any modification, it accepts. Okay, bind, non-terminating policy. Is there anything wrong we are doing here? Policy is a request policy, right? Okay, let's go to virtual server. So there are always two ways to bind a server. Go to the virtual server, go to the virtual server VG, go to the policy. Policy, just add. Now this is responder policy, right? Responder policy, the request. Responder request is sent to SSL. Select 100, next, bind. Non-terminating policy must have noop action. Is there anything? Nope. Action. Mm-hmm. HTTPS slash plus HTTP request hostname HTTP URL say plus HTTP request and, and query plus HTTP URL say 302 code. Not an issue. Close. Action. Action sent to SSL. Client SSL. Okay. This is request. Where we want to take a request? Where policy bind. No, it's not accepting. Another reason. Okay. Let's again go back to the app expert. Responder. Policies. Send to SSL. Policy manager. Load balancing virtual server. Load balancing virtual server. HTTP. LB virtual server. RPG SSL redirect. Continue. Here it is action. Send to SSL. And 100 by it's accepted. Don't know why it's sometimes it's an issue. Okay, so it is active now. Okay, now we can again type HTTPS. Okay, we are also start recorder. You can see HTTPS. Now see it's redirected from HTTP to HTTPS, and now here we can see you are getting a 302 status code. So page 302, not 200, because it's redirected. Okay, so this is moved temporarily. So this is a page which is redirected. See, the first request was HTTP 172.21.10.105. Okay, and the status code was 302 found. Okay, in a response header, we got HTTPS 172.21.10.105. Okay, when we got the response 172.21.10.105, then again we initiated with the 172.21.10.105 with the SSL. Okay, and that packet start. In the response, you can see response failed to load response data. That's okay, no problem. Okay, so this is how we can figure. Okay, so here we can use string maps. Okay, so using a string maps. Okay, alright. So in a string maps, what you can do here. Okay, if we find something in URL path. Okay, so based on that we can just configure a full URL. Okay, for that we can use let's see. Now if I just type http 172.21.10.101 slash Google, then it should redirect to Google only. But now see, now it's not possible because there is no policy configured for that. Okay, like Google, if I type Google, it should go google.com. If I type bind, it should go to bind.com. If I type Yahoo, it should go to yahoo.com. Okay, so string maps uh, are hash tables that are indexed by key. Okay, so contents in string maps consist of key value pairs. Typically, a string map is used to look up a key and find its associated value. Okay, so key and value. So based on the key, so Google is a key, and the value will be http colon slash slash www.google.com. So once you find a Google, then it will respond with its value. Okay, so we redirect to this value. So it depends what key and what value you are mentioning on that. Okay, to do that, what we can do, we can just create string maps. These are string maps. Okay, string maps, we just need to add search redirect. Uh, search redirect. So search RE, because this is very um, case sensitive and we want to match exactly the same. So search RE, search redirect, search read. So now we're going to add key and value. The key, we want to add key as suppose slash Yahoo, and the value will be http colon slash slash www.yahoo.com. Insert. Okay. Now one more key. It's a key just Google value http www.google.com. Insert plus slash bing that http slash www.bing.com. Okay, so we created the string maps, that is search underscore read. Okay, now based on that, we want to take an action. So we'll create a responder policy. So go to the responder policy. Okay, add responder policy, rs policy string map. Yes, what is that? String search redirect, right? Search read. Okay, we want to add action, responder policy, action, car search read, redirect. Okay, so the type. Okay, what's the type is? Type is redirect, right? We want to redirect something. Okay, so expression. So what do you want to redirect? Okay, so you want to redirect HTTP request URL path map string map string. What is a string? The string is you created search redirect search read. It's a string map, right? So HTTP request URL path map string with search read. So we will redirect with the search string. Okay. So HTTP request URL path. If we get a string, if a string is match in a string map, then that value and key will be evaluated. So based on that key, that value will be redirect. Okay. So create. Okay. So when you want to take this action, right? So to take an action when HTTP request URL path is string string macp. Okay, so HTTP request URL path is string macp. That's so simple. So what is our string macp? Search read. If I match that whatever in that search that string map, if it's match, then I need to take an action, right? Yes, so just type create. Now this is the policy. I want to take an action to bind it. So to bind at virtual server RBG, right? Continue. So this is search read, select and is okay, bind, done. You can just cross mark, just refresh page and it's binder. So just slash Google, or if you just refresh, now see, you can see the Google page because it's redirected. Okay, but if you check the Google page header, the previous request was http 172.21.10.101/Google. Okay, so the status code was 302 found because it was redirected. Okay, so when it was redirected, so in a response header we got that the location is http://www.google.com. So this is how uh, that string map works. So again, if you have http 172.10.101/Bing, see it's bing.com. Again the same. So if you look at the Bing, again the request was actually Bing 302 found and location is found bing.com. Same we can do http 172.21.10.101 Yahoo. Yahoo. This is okay. Now the basic thing, suppose in case future if there is a more request, okay, like that, then what we need to do, we just go to the search there. Okay, we just need to enter that slash Facebook. Then we just want to add http:// www.facebook.com. That's it. Insert. Okay, that's it. Now again, if you go here and just type http 170.21.101 slash facebook, I see, facebook.com website opening. Okay, so this is how string maps work. So it's easy. So it's like everything is binded, everything is configured. You just need to add key and value, then it will be in effect. Okay. Okay. Now we will redirect. Okay, we will use responder policy to redirect to imported maintenance page. Okay, so there are multiple options. So something, if something is going on server and we want to publish to client that if something is happening or maintenance time is going on or some service having an issue. Okay, so in that case we need to send a custom message or with some HTML page. Okay, so we can do that. So first go to the virtual server and create a virtual server with the LB virtual server maintenance. So LB ESRB maintenance server. Okay, so HTTP IP address is non-addressable. Okay, service. Okay, service we can add any unused service. Fake service we can use here because that is a false service. Okay, and continue and done. LB virtual server RBG, if it is disabled, then it will go to the LB virtual server maintenance. Okay, so make sure now LB virtual server is disabled. So in that case, everything will be down. There will be no any apply to the client. Let's see if we disable 171.10.101 and if we want to see 172.21.10.101, let's go HTTP. There is no any service available right now. The server is down. So you will not receive any proper response, okay, from the server. Okay, so for that, what you can do here, you can do an LB just server in protection. We can just add a backup virtual server. It will be virtual server maintenance. Just okay, done. But still you will not receive because virtual server maintenance also not having any idea about that page. Okay, so we will send a response page, okay, or custom message, three types. Okay, first we will we'll create an actions. Okay, responder actions. So go to the app expert, responder policies, responder actions. Okay. We will add. Okay. PC is getting it slow. Just a second. Okay. Ah, sorry for that. Okay. So here I'm going to take an action first. So responder action sent to maintenance. Okay. So the type of action is respond with. I'm going to respond with some particular message, right? So I'll type http slash 1.1 200 OK page r slash n slash r slash n is plus down for maintenance n t n a n down for maintenance is 1, so down for maintenance 1. So it will show the action 1. So this is respond to action 1. Okay. 1 slash r slash n, you are connected from client IP. So here dynamic response the client will get, that is client dot source IP plus colon slash r slash n slash r n slash n rn 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 rn. Okay, create client IP client.ip.source. Oh, client.ip.source. It is wrong. So client.ip.source. Okay. Yeah, created one action here. So this action will generate a standard 200 OK response. However, since this may be cache, so you may want to generate 503 service unreachable message. So for that, to add responder action send to maintenance 2 was respond with here http slash 1.1 503 service unavailable slash r slash n slash r slash n colon slash n colon plus the message down for and maintenance 2 plus down for maintenance 2 slash r slash n slash r slash n r slash n r slash n. You are connected from client IP plus client.ip.source plus colon slash r slash n slash r slash n colon complete. Create. Again, something is wrong with IP client.ip.source. It is right. Plus r slash n slash n. Down for maintenance to r slash n. You are connected from client IP. Okay, client IP. Here we are not close the okay. Create. Okay, so this is section 2. Now we want to also respond to the proper HTML page also. Okay, so in that case, okay, so first we need to import an HTML page. So that HTML page we need to import first. Where is that HTML page import? Page add. Okay, so the page maintenance page maintenance page import from URL. The URL is http 192.168.30.51 slash main.htm. Okay, continue. Okay, so this is the page which is we want to import. Done. Okay, so again go to the responder policies actions. You want to add that responder page here. So rs responder action send to maintenance 3. So maintenance 3 is anything where to respond to the HTML page. So it's a 200, that is maintenance page. So but response status code will to 503. Okay, and this is the maintenance page. Okay, create. Now go to the policy. Responder policy add. Responder policy POL send to maintenance. Okay, so action. So there are 3 actions. First we will check maintenance 1. Okay, but when you want to take an action, then HTTP request is valid. HTTP request is valid. If I get HTTP request, then it's valid. Create policy manager. We want to take an action. Load balancing virtual server 172.21. So where we want to apply? We apply under LP virtual server maintenance because that the server is responding for that. If I get HTTP request on that server, right, maintenance server, then I will respond with this, right? What is the policy? HTTP sent to RS pole sent to maintenance, right? Done. Okay. 172.21.10.101. If this is a request, you see, down for maintenance 1. You got a reply. But see, status code is 500. So 200. 200 is okay. That's okay. Which send 1. Okay. But this is not the so in a response we got that. So my actual IP is 172.10.254. Okay. Now what we can do? Go to the responder policy into maintenance and change the action maintenance 2. It will show you that purchase record. Okay, and again just refresh the page. See, showing maintenance 1 and just refresh. See, it's down for maintenance 2, but here you're getting error code 503. Okay, now again go to the same to maintenance and change it to maintenance. Here you will get the HTML page, right? Because the same page you have imported. And now if you refresh, see, we are getting a proper response. Oops, sorry for the inconvenience, something broke. So this is the response. It is a 503 only, but see, in header we are getting the 503 service unavailable, and in the response we are getting that all the response page. Okay, so this is how we can respond for the maintenance web page. So this is how we can use responder policies. Okay, now we will see the content switching. Okay, so the content switching, there we have a request like that. If there is a one server, okay, virtual server, okay, now virtual server we're having 3 servers behind that. So red, blue, green. Okay, just on. We have 3 virtual servers: red, blue, green. Okay, but there's a request. If the request comes from iPhone, then it should redirect to the red server. If requests come from Internet Explorer 6.0, then it should directed to blue server, and all other requests should direct to green server. Okay, so this is a server. This is the requirement. Okay, so to fulfill that, first we need to check that content switching feature is enabled. Content switching, yes, it is enabled. No problem. So for that, first we'll create expressions. First we'll with that expressions. Okay, we want to match interesting traffic first. So the expressions first for iPhone. Okay, so iPhone is like HTTP request header, that is user agent, HTTP request header user agent. It contains iPhone. HTTP request header user agent contains iPhone. Then it's a interesting traffic. I'm interested in that. Right? Same like we want to add one more is for Internet Explorer 6. Okay, IE6. Okay, it's expression name. Okay, so in that case, same HTTP request header, HTTP request header, that user agent, user agent contains user agent contains MSIE 6.0. That's it. So create. So this is the interesting traffic which we have created. Now we will create content switching policies. Go to the content switching policies. The interesting traffic we have map with the expressions. Now we create a policy for that. Okay, so the policy for CS policy for mobile, that is iPhone, you just say want to take an action. No, we don't want to take an action. We just policy, but in expression we are going to match our expression which you have just created, that is iPhone, that is created. That's it. CS policy mobile plus CS policy legacy. This is for Internet Explorer 6. Okay. And for that also we have created expression I6 create. Okay, we have created both the bus. Now go to the load balancing virtual servers and see there are no red, blue, green servers as a load or the virtual server. So we need to add it. Add LB VS red protocol HTTP the address, it is non-addressable. Okay. So service, we are going to add service rate. Service rate, select bind. Continue. Done. Okay, plus LB virtual service blue be HTTP, this is also non-addressable. Okay, service binding blue bind continue. Done. See, blue is also up, and the last one is green. LB vs green. Protocol HTTP is also non-addressable. Okay. Load balancing, server binding, green. Select, bind, continue. Done. Okay, traffic management, content switching. Okay, content switching. Okay, content switching, virtual servers. Okay, so you're going to add content switching, VSRV, RBG, red, blue, green. Okay, protocol HTTP, target address, IP address. We are going to provide new IP address 172.110.106. 106. Okay, create. Okay, content switching policy bound. Okay, so here we are going to match the policy. We have two policies. It's a mobile. Just select a mobile. Select 100 party next. Okay. Okay. Target load balancing server is RAID, right? RAID. Select. Bind. Go to expression is invoke. Present. And bind. Plus content switching policy. Add. CSS policy. Legacy. Select is, and legacy should go to the virtual server blue. Select, bind, close. So default virtual server should be green. So if request not matching the server, green. Okay, green. Okay, now policy is ready. Let's see how it works. For that we require a Mozilla, because in a Mozilla we have plugins to use Internet Explorer and iPhone. Okay, let's see. HTTP 172.2110.106 slash home.php. We are the IP address is wrong. 106 green. See, we are getting a green. Why we are getting a green? Let's see. As per the policy, to get a blue or red, okay, so we will get a red only when request received from the iPhone, and for blue if we get a request from a Internet Explorer 6, okay, as a user agent. But this is Mozilla, okay, so it can say user agent. What's a user agent is? User agent is Mozilla Windows NT. So this is not matching. So if it is not matching, then by default the request will forward to the green server. Okay, so now we will change the user agent to the iPhone. Okay, let's see. Now this request is sending through the iPhone, then its request should match that content switching policy, and that response should get from red server. Let's see. See, this is, we are getting a response from server red. Okay, let's see how we are getting this. If you see the page, the user agent, okay, the user agent saying it's Mozilla, but in this user agent it's contain iPhone, and this iPhone is matching the policy. Okay, now we want to change from Internet Explorer 6, and we'll see the request. But still it is going to, whether I'm going to Internet Explorer, but still it is going to green. It's not matching as per the policy the blue server which we are expecting from blue. But why you are not getting from blue? Let's see. Refresh, and here you can see in user agent it's Mozilla Windows NT 10.0 64 3.7.0 RV11, like so there is nothing mentioned in our which you mention in a string that MSI 6.0. So what we can do here, we can match this parameter RV11.0, right? So just copy, go to the, it's a parameter and app expert, uh, expressions, advanced expressions, and for where is that, on second page, MSIE, that this is not available, right? MSI 6.0 is not available user agent, so this is available in user agent. So just okay, okay, that's it. Now again just clear the logs, just go to the page. Now it should respond with the blue server. Let's see. Yes, we are getting prompt response from blue server. Let's see the see user agent is Mozilla 5.0, RV11.0. So RV11 is now we are matching there, so that's why we are getting a response from this. We can see hits for that, hits on content switching policy. So let's go to the content switching policy, traffic management, content switching policies. See, there are hits. It's matching traffic. That's how content switching works. Okay, so configure content switching a content type. Also, we can do that. Need to get PMG pattern sets. Yes. Okay, so now we'll configure a Gslb. Okay, so configuring a Gslb. So this is my site. This is my one site, Frankfurt. Okay, and I have a remote location. Okay, in a Tokyo. Let's close this. Okay. Let's see if my remote location server is enabled. I need to enable. Okay, this is not enabled. Let's start. C01 doc start. Start. Okay, now it is starting. Okay, so in this task, we are going to configure a GSLB between Frankfurt, Germany, and the other is based in Tokyo, Japan. Okay, and URL we are going to use is http:// globalweb.workspacelab.com. Okay, so first we will create a GSLB sites. Okay, and active, then active passive. Okay, so hope this server is live now. This will come up. It is just uh, rebooting right now. No problem. So first we will create a virtual server that is require. Okay, that will be the part of our GSLB. Okay, so just create a load balancing server LB VSRV FFM HTTP protocol you're using, that's okay, and we are using IP 172.21.10.122 protocol. It's okay. We are just attaching the sides green. That's okay. Bind. Continue. Done. FFM is added. No problem. Now the GSLB GSLB feature is enabled because there is no any yellow symbol. Okay, so first we will add sites. Okay, so first we will add sites, site FFM type. It will recognize automatically based on the IP address. So my IP address is 192.168.10.103. That's it. Create a site. Create. These added. Now I want to create. I want to add a remote site. So remote site is site Tok. Site Tok for Tokyo. That's okay. IP address is 172.22.15.211. Create. Okay, site is created, but it's not up because the remote site is still not configured. Let's reconfigure that remote site. Okay, so this is my Tokyo ADC, NS root, NS root. So we log into this remote network. First see whether the feature is enabled. Traffic management, GSLB, load balancing. The load balancing also is not enabled. So just enable feature. Content switching is a content switching not required for us, but GSLB required. GSLB enable feature. It's enabled now. Okay, so GSLB is enabled. Okay, so right now we will create a GSLB. Sites, add site name, site Tok, IP address 172.22 15.211. Okay. Okay. So also we will add a remote site FFM. Site IP address is 192.168.10.103. Create. Now so just refresh. See, it is up. So synchronization is up. So site metric status is up now. Okay. Now again back to Frankfurt ADC. Sorry. Okay. So once GSB sites have been configured with valid IP addresses on both Citrix ADC appliances, metric exchange protocol is successful and MEP status for the remote side on each respective Citrix ADC will now be up. Okay. So confirm that SNIP IP which is using power Gslb. So IP in a network, check the IPs. This is one using a Gslb site IP, and here also you will find 192.168.10.103 and Gslb site IP. That's okay. Now on this server we are going to add a Gslb services. Traffic management, Gslb services, I'm going to add Gslb service FFM, Gslb service FFM, so site FFM, IP base address 80, so backend virtual server is virtual service FFM. 10.10. Okay, that's good. Okay, done. Effective state is up. This is a backend service. Okay, also one more service we will add, that is for Tokyo. So GSLB service Tok site Tokyo base, and we don't have that server directly on our LB, so we just add a server IP that is 172.22.15.231. 172.22.15.231, it's a virtual server, right? Now let's refresh. See, it is up. Even though there is nothing configured in GSLB except sites in Tokyo. Let's see, GSLB, we have configured only sites. There is no any services, no any virtual servers currently, but still for mine it's up. Okay. Now we will create a virtual server for Gslb. Add Gslb VSRV global HTTP. Okay. No GSLV service binding, so we have two services to bind it. That is service FFM, service token. Select bind. Okay. Now no GSLB server domain binding, that we need to bind it here. So what is the server domain? That global web dot workspace lab.com. Global web dot workspace lab.com. This is the domain which you want to bind. Now this method we want to change. It's not a list connection, we want to send it round robin. Okay, done. We created a global server which is service. Okay, now to check that we need to change our server from front end properties TCP IPv4 the DNS code should be directly my LBVIP DNS server. Okay, so this is called DNS proxy, we can say. Okay, so that is 172.10.102. So this is server here. It's close. Okay, now we will see from command line ping -c to global web dot workspace lab.com. Oh, wait, -c it is not required here, right? Global web resolving with 10.122, 172.21 and 172.22.15.231. So you can say we are getting reply from both the IPs. 21.10.122 and 172.22.15.231. So it is getting load balance. So GSLB load balancing is happening right now, but still we have not sync this configuration. GSLB synchronization, if you see, there is nothing. If you see the dashboard, there is also nothing because we have not synced the configuration. Here showing the services are showing to up, but if you check at virtual servers and services, there is nothing. Just because we are not synced. So to sync, that's it. Go to the dashboard, auto sync, force sync, site run. Let's see. Retrieving all percentages sites. Okay, retrieving in local site info, site talk slave. Oh, it's taking too much time. Okay, so we are getting error executing command JSL error connection failed. So configure local GSLB site or the site enable management access to GSLB site IP using a set IPNS command and configure the firewall to access. Okay, so here the issue is the remote and SNIP not having a management access. GSLB. Here it is enable management access. Allow access onto the management applications. Telnet TP. Okay, done. And now just get run. So now it is synchronization successfully done. Right? Close, close. Now we can see GSLB status at Tokyo ADC, the traffic management, GSLB virtual server is available, services are available, domains is now showing there. Okay, so this is how GSLB works. Now synchronization done, policy configuration done. Okay, the one thing we want to see, this is active right? So we want to do the active passive. So how to do the active passive? Go here, go to the virtual servers. Okay, add one more virtual server. Okay. GSLB virtual server backup. GSLB VSRV backup. Backup. Okay. In a backup, the service we want to bind, that is for Tokyo. Okay. 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 Done. And from GSLB virtual server global, if there are two services, remove the Tokyo. Now only if my primary server goes down, the secondary backhaul server will be also active passive. So let's make virtual server down, virtual server, LV virtual server FFM, disable. Oh, before that, first we need to see we are getting a reply from HTTP. What is the URL is? global web, global web dot workspace workspacelab.com. So this is the URL which currently we are getting. So this is globalweb.com. Think we need to enter something else. Home.php or remote.php slash remote.php. So this is going to the in-hard is a German server. Now it is stick to that. And if you open the Internet Explorer, oh, we have already removed that, so that's why it's not getting load balance. Okay, no problem. So we just disable. Now this is not the active now. Now it will go to the Tokyo. So you will find some Japanese language here. So this is unavailable. Service unavailable. Okay. Why the service is unavailable showing? 20.10.1 that is service unavailable. But if you look at the traffic management, virtual server, just Gslb, virtual servers, this is still up. Oh, but we not have configured a backup virtual server here, right? So we need to configure a backup virtual server is Gslb virtual server backup. That we need to configure first. Okay. Now we can see our backup virtual server is up. We need to redirect to the backup virtual server, which is Japanese. Okay, so in 172.22.15.201, let's see how the connection is. Diagnostic connection table. Monitor connection, view TCP IP connections, view all connection, continue. This is the communication. So it's connecting on 172.22.15.231, right? But here it is not that information which you require. Okay, let's connect ADC New York ADC 003 NS root show connection. Show connection table. Okay, connection table GREP 172.21.10.254. Is there any connection? No. So connection for 172.22.15.230 Oh, how it is resolving now? 172, 15.231. 172, 22, 15.231. There is also no any connection table. How's that? Okay, let's connect again. First, resolve the query. 172.22, 15.231. 172, 22, 15.231. 15.231. Okay, let's see. Okay, so here I'm connecting there directly to the V, which is my source. Here is taking 172.22, 15.254. Okay, so 172.22, 15.254 is this is SNIP. Okay, but we want to know what is the source from the Frankfurt, from Germany. It is receiving. Okay, for that, what we can do here, you can just start new trace, size 0. Okay, here we are going to just write connection IP equal to 172.22.15.231, right? So this is what IP 172.15.231 is the IP which we want to write. Done. Start. Okay, started. Now I will send a request. Generated traffic from my machine. Now we will stop the trace. Stop and download. Let's download and open. Okay. 172.22, 15.231 and 15.254. What is that? 15.254 and 15.231 is the actual IP. So let's see what is the backend IP it is using. Let's see system network IPs. 172.21, 15.211 is the backend IP. Oh, and 22.15.231 is my virtual IP. Okay, so 211 to 231 there will be a hash. So what is that? Okay, let's go to the system network IPs. We don't have anything to do 172.22. This is through external service, right? So it will not hit because I'm hitting directly. That is not part of my system, so it may use some different source IP. That's okay. That's not a problem because it will not go into my server. So whatever the public IP they have, so I will use it. No issue. So this is how uh, load balancing works. Let's see. Next, thank you.